All right, today we're going to be in lesson 2.7 and 2.8 and talking about solving proportions. And really, the rest of this chapter, lesson 2.7, 2.8, 2.9, and 2.10, are all about solving proportions. We're just going to look at how we use proportions in some specific situations throughout the rest of the time. But today, as we get started in lesson 2.7, we're going to look at the basics of what is a proportion, what are our steps to solving it, and then look at a few examples of how we apply those steps to some different math problems. So we're going to begin with just the basics. What are proportions? Here's our definition. A proportion is an equation that states that two ratios are equal to each other. And so because we are starting with this definition, we probably need to back up just a little bit and look at really what is a ratio, since a proportion is two ratios. We're going to begin with what a ratio is. And a ratio, if you'll put it here on your notes, a ratio is really just a comparison. And what we are comparing when we are looking at ratios is we're comparing two amounts or two quantities. So for example, like if we said we have 2 apples, and every time that we have 2 apples, for every 2 apples that we have 5 oranges. This right here, this comparison that we just wrote, that's a ratio. It's a comparison of two amounts. And so a proportion is when we have another ratio, right? We have a second ratio. And what we know about those two ratios is that those two ratios are equal to each other. Those two ratios are equal to each other. So for example, if it's true that for every 2 apples we have 5 oranges, then it would make sense that if we doubled our amount of apples, that we would also double our amount of oranges. So if we had 4 apples, then obviously we would have 5 oranges as well. And so this entire thing right here, these two ratios that are equal to each other, this is a proportion. And so we're going to talk today about how we use proportions to solve problems, how we write proportions, and really our steps for when we are missing one of those kind of 4 pieces of the proportion. How do we solve for it? How do we find the missing variable? So that's what we're going to dive into next. So let's start here. Let's start with a basic proportion. And before we begin, again, obviously this is a proportion because we have right here 2 ratios. And what do we know about these 2 ratios? We know that they are equal. And so our equal sign tells us the 2 are the same. And that's what makes this a proportion, the 2 ratios that are equal to each other. And so we're going to walk through this first one with just kind of some basic steps for how we solve them. There's really 3. And so we're over here to the side. Underneath solve, if you'll put to solve, and we're going to go through these 3 steps and write them down together. There's a couple different ways that we can solve proportions like we looked at on the last slide. Sometimes it's just as simple as you can multiply the top and bottom by the same amount, and if we do that, we can figure out whatever it is that we're missing. Other times that's not as easy to do, like in this case, 8 times not a whole number gives us 12, and so when that's the case, when we're just don't have an easy multiply the top and bottom by the same amount, we can solve proportions in these 3 steps every single time. And so it doesn't matter whether it's a simple proportion or a more complicated proportion or a word problem or later when we're dealing with percents. Here's our steps. If we follow them each time, then it works to finding our missing variable. So step number 1 when we're solving proportions is we're going to cross multiply. And cross multiply means that we're going to multiply the 2 values that are diagonal from each other. So our first thing we're going to multiply is 7 and 12 because they're diagonal from each other. So we have 7 times 12. And then the second thing we're going to multiply is 8 times m because they are diagonal from each other. So we have 8 times m. So step number 1 when we're solving proportions is cross multiply. Step number 2 is that we know that those 2 products, the answer to those 2 multiplication questions, the products that we get are equal to each other. So when we multiplied 7 and 12 together, we got 84. When we multiplied 8 and m together, we got 8m. And what we know about those two is they're equal to each other. Those two products are equal to each other. And then step number 3 is where you're going to solve for the variable. That's the third step, solve for the variable. And we've already walked through all of those steps. Do you need to distribute? Do you need to combine? Are all of your variables on the same side? Is your variable by itself? And so as you go through those steps, we solve for the variable, we get the variable by itself, and we find that missing value. And so in this case, no need to distribute, no need to combine. All the variables are on the same side. All that we have is that the variable is not by itself, and so we need to get rid of what's with it. And so in order to get rid of this times 8, since they're right next to each other, it's multiplication. We do the inverse operation, which would be divided by 8. And then because it's an equation, because the two sides are the same, if we change one side, we have to change the other the same way. And so we divide by 8 there as well. And then we solve. So 8 divided by 8 is 1, or 1m, or just m we can write it as. And then on this other side, as you've seen over these first couple of chapters, so many times in 8th grade, we don't want decimal. We don't want mixed number unless it's specifically asking for it. So there's our answer, like it's already answered for us, 84 over 8. The only thing we need to do from here is just, do we need to simplify? And so in this case, we can divide both by 4. 4 is the greatest common factor that goes into both 84 and 8. And when we divide them by 4, we get 21 over 2. And there's our simplified fraction for our answer to this problem. So solving proportions, 3 steps. Cross multiply. We know that the products are equal to each other, and then we solve for the missing variable. All right, let's take a look at another example. Maybe getting a little bit more challenging here. Again, 3 steps. First step is we're going to cross multiply, and so we're going to do 4 times 8 minus b. And we're going to do 5 times 8 plus, or times b plus 3. When we do those, just a reminder from order of operations, when we have more than one thing on the top and bottom of a fraction, those things are grouped together, and so it's like they're in parentheses. So our 2 multiplication problems that we're going to have are first 4 times b minus 8. And then our other multiplication problem we're going to have is 5 times b plus 3. So first step, cross multiply those things that are diagonal from each other. And then what we know about those 2 products is they're equal to one another. And then from there, we're solving for the variable. And so first question that we always ask is, can we distribute? And in this case, yeah, we have a set of parentheses, something on the outside, and so we can distribute. 4 times b is 4b. 4 times negative 8 is negative 32. And then on the other side, 5 times b is 5b. 5 times positive 3 is positive 15. So can we distribute? On each side, no like terms to combine on the left side, no like terms to combine on the right side. So then we need to get all of our variables on the same side. In this case, they're not, so we either need to get rid of the 4b or the 5b. I would rather get rid of the 4b, and so the way we get rid of a positive 4b is we do negative 4b or minus 4b. And then what we do to one side, we do to the other. So also negative 4b or minus 4b on that side. And we go straight down. 4b minus 4b is nothing, so we're left with negative 32 on this side. And then on this side, 5b minus 4b gives us 1b, or just b. Those two things are the same. And then 15 and nothing else gives us still 15. And bring down our equal sign. All our variables are now on the same side, so our last step is get the variable by itself. In this case, it's not. There's a plus 15 with it. So the inverse operation of plus 15 is negative 15 or minus 15, and what we do to one side, we do to the other. Positive 15 minus 15 is 0, so that cancels. We're left with b on this side. And then over here, our rules, same sign, we add, different signs, subtract, keep the sign of the bigger number. So in this case, they're the same signs. We're going to add them together. And we get 47. And then we keep the sign of the bigger number. 32 is bigger and it's negative. So our answer is negative 47. So if we replaced b in our problem with negative 47, that would be our correct answer. All right, third example, last example for this this video and these sets of notes is looking at a word problem. It starts exactly the same way, like we have a comparison of two amounts. The two amounts that we start with that we have the comparison for is for every 2 gigabytes, those 2 gigabytes can hold about 500 songs. Cursor here, there we go. About 500 songs of storage, and so that's the ratio we begin with. 2 gigabytes holds 500 songs. And then when we are writing proportions from word problems, we need to make sure our biggest thing is that we label. And so since gigabytes was on top, then in our second ratio, gigabytes also needs to stay on top because we're comparing the same two amounts, and songs was on the bottom before, so songs needs to be on the bottom in our second one. And then we're looking at the question and we're filling in what we know. It tells us that a similar media player has 80 gigabytes of storage. So here next to gigabytes we're going to put 80. And the question asks us about how many songs, right? That's the part we don't know, and because we don't know, we're going to put a variable there. You can choose whatever variable you want. I like to choose variables that make sense so that when we are done, we know what they actually mean. And so I'm going to go ahead and call songs S songs. And we want to know how many S songs can the larger media player hold. And so again, hopefully we can begin to see some of these easier ones, right? It's 40 times as much to get from here to here, so it's going to be 40 times as much to go from here to here. However, as we talked about, if we don't see that, or if we don't even want to mess with it, we can always cross multiply. And so our first multiplication problem would be 2 times S, which is 2S. Our second problem is going to be 500 times 80, which is going to be 40,000 when we multiply those two together. And what we know about those products is they're equal to each other. And then we're solving for the variable, last step. And so to get rid of the 2 that's with the S, since it's multiplication, we're going to divide. That's the inverse operation. What we do to one side, we do to the other. 2 divided by 2 is 1, or 1S, or just S. And then on this side, 40,000 divided by 2 is 20,000. And so we get in the end, S is equal to 20,000. And once again, that's why we write the variable the way that we did. What does S stand for? S stood for songs. The question was about how many songs could it hold. It could hold about 20,000 songs to answer our question. Awesome. Well, that's it. That's the start of proportions. Proportion is two ratios that are equal to each other. We solve it by cross multiplying, knowing that those two products are equal to each other, and then we solve for the variable using our steps to solve. Over the next couple of videos, we're going to look at some specific ways that we apply proportions, but every time, these are the proportions that we write. This is how we solve proportions. So we'll pick it up here soon. Awesome.